Welcome all. Welcome to my pipeline stress analysis course using Caesar 2. So in this module, we will learn about the differences between piping versus pipeline. Means what are the major differences between piping and pipeline. So both piping and pipeline originated from mechanical engineering and many a times share common activities. This means that both piping engineering as well as pipeline engineering are part of the main or mother branch mechanical engineering, and in most of the time you will be finding that the activities that are performed by a piping engineer or a pipeline engineer are almost the same. For example, both have piping materials, piping expansions, stress problems, support problems. So both piping and pipeline need stress and materials engineers. Both piping and pipelines are used to transport fluids. It may be liquid or it may be gas. Now refer to figure 1, which shows the demarcation of piping and pipeline. So in the next slide, I will show you an example where I have marked that from where we consider the system as piping and from where we consider the system as pipeline. In general, piping is considered to be inside the fence boundary, while pipeline is considered to be outside the fence. See, this is an example. Here you can see that this is the fence, and whatever is inside the fence, that is usually within the piping scope. Piping scope means the system will be designed based on different code. So what are those piping codes? The piping codes are usually ASME B31.3 for process piping or ASME B31.1 for power piping. So here we are mainly considering related to oil and gas industry. So the piping part will be designed based on ASME B31.3, whereas the pipeline part, if it is a liquid pipeline, it may be based on ASME B31.4, and if it is a gas pipeline, it may be based on ASME B31.8. So here at these interfaces of the flanges, uh, normally the demarcation exists, and the actual demarcation you have to find from the process PNID, means piping and instrumentation diagram. So in those PNIDs, they will be specifically marking that from where the actual code break, means B31.3 versus B31.4 or B31.8 happens. So based on that, you have to use the design code in your stress analysis system. If your system consists of both B31.3 as well as B31.4 or B31.8 scope. Now, what are the major differences we will find? That on a broad scale, ASME B31.3 or ASME B31.1 deals with the piping engineering, whereas ASME B31.4 and ASME B31.8 deals with pipeline engineering. So other differences between piping and pipeline systems are, generally a pipeline travels a long distance. It may cross villages, it may cross countries, cross country pipelines we may say sometimes. So whereas this length of single piping is usually short, so it normally starts from some equipment to equipment or equipment to pipeline or to other equipment. So piping and pipelines are normally demarcated by a boundary or fence. Outside the fence comes under the pipeline scope, whereas inside the boundary falls under the piping scope. So this is one of the major difference between piping and pipeline. Next, piping is normally connected with various equipments and carries fluids inside a complex network that will be processed in that equipment. So whenever some equipment is there, it may be that that fluid will be processed inside that equipment, and because of that piping network is required, which is normally a very complex nature, whereas pipeline systems are feed for the further processing or deliver the processed fluid, Means it may be such that that pipeline is feeding into the piping system which will be processed inside equipment. Means let's assume that it is a crude oil. So crude oil will be transported through the pipeline systems into the piping system, and then it will be processed inside the refinery. And once the exact processing is done, then output fluids, means our petrol, diesel and other products may be transferred or transported again back using pipeline systems. So whereas pipelines supply the feed for further processing or deliver the processed fluid or end product, and they normally run straight. So there are no much changes in their route. Usually they run straight. The number of equipment connections in the pipeline system is very less as compared to the piping. So this is the second difference. Next, pipelines travel above ground, underground, or subsea, with the maximum part being buried. So, in general, pipeline systems, maximum part of the pipeline system are underground or buried, whereas piping systems are mostly above ground. In piping systems, pipe size is normally less. The majority of lines in the process or the power piping systems are less than 36 inches, but the number of pipe fittings used is very high. Means even though the pipe size is less, but due to various directional changes and branch connections, the number of pipe fittings in piping system are usually very high. On the contrary, pipeline diameters are large because normally they are used to transport a huge volume or huge quantity of liquids or fluid gases, so their diameters are usually large, and the number of fittings is comparatively much less. Number of fittings used means elbows, bends, T connections, flanges. So those type of fittings are usually less. In most cases, fluid design temperature for pipelines is normally less than 230 degrees centigrade. So as per the ASME B31.4 or B31.8, pipelines are usually have less than 230 degrees centigrade, whereas piping systems carry fluids with very high design temperatures. Now, in most of the cases, pipelines, line pipes or API 5L code is used for pipeline material, and API 6D is used for pipeline valves, whereas piping material uses ASTM, BS, API 5L or various other codes and standards, and piping valves are from BS or API standard. For the piping system, the hydrotest pressure is calculated by multiplying the design pressure by 1.5 and a temperature factor, whereas pipeline design pressure is usually 1.25 times the design pressure for liquid pipelines and 1.25 to 1.5 times the design pressure for gas pipelines. Also, the pressure holding time for pipelines is normally 24 hours, whereas for piping system, the same is usually 2 to 6 hours. So during hydro test also there is a difference between piping and pipeline system. Now while routing pipelines, large diameter elbows, normally hot bend up to 6D and cold bend up to 60D, are used, whereas piping systems usually used exact fittings, standard fittings, 90-degree elbow, 45-degree elbow, this type of, and you in general do not find such large diameter bends. The construction drawings in the case of pipeline systems are termed as alignment sheets, whereas for the piping system, the construction drawings are termed as piping isometric drawings. Means pipeline system is constructed at site from the alignment sheets, whereas piping systems are constructed at site from piping isometric drawings. Now various technical surveys like topographical survey, soil resistivity survey, cadastral survey, hydrological survey, geotechnical investigation report or survey, etc. are performed to collect various data during the pipeline design, whereas only wind and seismic profiles are studied for the piping systems. Now long pipelines are cleaned and inspected by using pigs, whereas piping systems are cleaned with steam or nitrogen. Some other differences are pipelines are normally preserved using inert gas or corrosion inhibited water. Cathodic protection systems are followed or involved with pipelines. Corrosion protection coating is normally applied for pipelines, whereas piping systems are usually painted. The pipeline runs across rivers, below railroad, highways, etc. Hence, special design and constructional considerations are required, whereas piping systems are usually not required this type of considerations. So hope you understood the main or basic differences between a piping or pipeline system. So that's all for this module. Thank you. Happy learning.